Good morning, everybody.
Good morning.
How are you all?
Fine.
Fine. Answer your attendance. Afla,
Present, Miss.
Ajmina,
Present, Miss.
Amaya,
Present, Miss.
Atulya,
Present, Miss.
Drishya. Drishya is not there. Jyotish,
Present, Miss.
Karthik, Kavya,
Present, Miss.
Nachiket. Okay. Neeraj. Neeraj is not there. Rangit, Vaishna,
Present, Miss.
Vaishnav, Vaishnav, Anjali,
Present, Miss.
Anjali is there. Okay.
Present.
Shruti.
Present, Miss.
Okay. So absent is Drishya, Neeraj, and Rangit. Okay. Neeraj, can you summarize what we have learned in the last class? Neeraj? Oh, sorry, Neeraj is absent, right? Okay, sorry. Shruti, just summarize what we have. Shruti was there. Okay, yeah, she was there. And summarize last class. What we have learned in the last class.
Error detection.
Yeah, error detection.
Error detection.
Okay. Now, what are the different error detection methods? What are the different
CRC,
CRC? What is the full form of CRC?
cyclic redundancy check.
Okay, cyclic redundancy check and
Checksum.
checksum. So you have 4 are there, but you have to study only 2 detection methods. One is called it as the cyclic redundancy check, and the other one is called the checksum. Have you gone through that slides, that binary division, what I have sent last day? Have you seen it? No, nobody is telling an answer. Kavya, did you see that? How the binary division is done in CRC generator. Kavya, did you see that?
Present.
Yes, okay. Now, coming back and up to, I think, Jyotish Karthik. Why the other students have not called me? Only up to Kavya. You people have called me, and after register number 9 to 16, I have told you, continuously 4 people should call me. Okay, today the remaining 4 has to call, and tomorrow the remaining 3 has to call. Okay, so we will start our topic today. Now, last class we were dealing with the error detection schemes. Okay, and also I was telling about the functions of data link layer. Generally, you can have 2 different functions in all together in a consolidated manner. You can tell that one is data link control and another one is the medium access control. Now, under data link control, you have seen what is framing, what is flow control, and what is error control. Now, today you are going to see what are the medium access methods. This is the another function of data link layer, and that is the medium access methods. I hope you can see these slides. Does anyone reply? Yes or no?
Yes.
Can you see the slides? Karthik? Yes, okay.
Yes, Miss.
So you are going to study about the medium access methods, or you can also call it as the multiple access methods. Okay, now I have told the data link layer is divided it into, you are having 2 functions that I can just tell that data link layer is subdivided into two layers. The upper layer is called the data link control and the lower layer is called it as the MAC layer or the medium access control layer. Okay, now in the beginning classes, I have told you about multi-point connection. Now what is a multi-point connection? If many devices, if they share a common link, you can call it as a multi-point connection, right? If many stations are there or many nodes are there, if they share a common link, you can call it as a multi-point connection. So, when nodes or stations, if they are connected using a common link, the one which I told, that is a multi-point connection, there is a need of multiple access protocols to coordinate the access to the link. The meaning is you need some procedure to handle the access to the link. You need some procedure to handle the access to the links. So that procedures generally you can call it as protocols. Now you have got different types of protocols, that is the multiple access protocols. The first one is called it as the random access protocols. The second categorization is the controlled access protocols. And the third one is the channelization protocols. So what I told is in a multi-point connection, you need some procedure to handle the access to the medium, to a shared link. So you are having some protocols that are called as the multiple access protocols. And generally you can have three categorization. One is the random access protocols, the other one is the controlled access, and the third one is the channelization protocols. In your syllabus, you have to study only the random access protocols. And in that, the last two you have to study, that is called it as the CSMACD and CSMACA. Now, what are these random access protocols? Now, in a random access, or you can call it as condension method. Condension method means some argument, or in Malayalam you can call it as tarka. Okay, so in random access method or in condension method, no station is superior to another station. The meaning is no station has the power to other station. No station has the control over the other station. Okay, so if a station has a data to send, you have to follow some procedure. Okay, and that is defined by the protocol. Okay, and that protocol determines whether the station has to send or not. Okay, and whatever decision they are taking, that is mainly based on the medium, access of the medium. They will check whether the medium is idle or whether the medium is busy. Understanding? In random access protocol, none of the station is having the control over another station. So if a station has a data to send, what it will do is it will follow some procedure, and that is defined by the protocol. Okay, so based on the protocol, and their decision will be taken, and mainly that decision is based on the access to the medium. Okay, so access to the medium means they will check whether the link is idle or busy. Okay, and also there is no specific scheduled time for a station to transmit. So it is not compulsory that at this time one station has to transmit. So there is no scheduled time for any station. Okay, so whichever station, so transmission you can call it as it is random. It is random among the stations. So it is called it as random methods, random access methods. Understanding? There is no scheduled time for a station to transmit. Transmission is random, so it is called it as the random access protocols. And also, there you don't have any specific rule that tells that this station should send next. So if one station is wanted to tell, there is no, if many stations are there, there is no specific criteria that this station should send at a particular time. So what all these stations will do is they will compete each other to access the medium. So what I told is they will compete each other. A competition is happening between the stations to access the medium. So it is also called it as the contention method. So it is also called it as the contention method. So I have told random access method, you can also call it as the contention method, and that is the meaning of that. Understanding random access method, none of the station is having control over other station. If a station wants to send a data, they will follow some procedure, and that is defined by the protocol. And if like why it is called random means you don't have a specific rule or a specific time for a station to transmit. So it is random. Whichever data a station wants to transmit, they will transmit in a random manner. But before transmitting, they will follow some procedure. Okay, and also how many stations are connected on the link, they will compete each other to access the medium. So it is also called it as the contention method. Okay, now every station has the right to the medium. All the stations are equal. So every station has the right to the medium. So if all are having the right to the medium, then sometimes the conflict or collision can happen. So every station must follow a procedure stating that each should be knowing what is the procedure they have to follow. When can the station access the medium? What can the station do if the medium is busy? Now, how can the station determine the success or the failure of transmission? Now, what happens if there is a conflict? So all these stations must follow these questions or these, they should find an answer. So when can it transmit? What happens when they transmit? If collision happens, what happens? What they will be doing it, and how they can determine whether the transmission was successful or it was a failure. Okay, understanding? So beginning, I started with the medium access method. It is one of the functions of the data link layer. So data link layer, you can just divide it into two separate layers or two sub layers. One is the data link control. You can also call it as logical link control. And the second layer is the MAC layer, medium access control layer. Okay, so medium access control layer resolves the conflict to the medium. So means all these, whichever stations want to transmit the data, they will follow some procedure. And you can call it as random access protocols. Okay, so random access is also called it as the contention method. So contention means every station compete each other for the medium. Okay, so there is no specific rule that this station should transmit at a particular time. All will be, the transmission is random also, and all will be competing each other. But they should follow a procedure when they are accessing the medium. Okay, understood this much? What is the concept of a random access method? Nachiket? Understood? Yes, okay. Now coming back to the slide. So I have just told you can just divide it into three different types and you have to study the first one. Now, the evolution of a random access method. So beginningly, in order to avoid the conflicts to the medium, initially the multiple access methods was developed. After that, the second method called the carrier sense multiple access method was developed. And later that, due to the necessity of the, how to control over the link, you can, there are two different methods. That is, one is called it as the CSMACD and CSMACP. Its full form is carrier sends multiple access with collision detection, and carrier sends multiple access with collision avoidance. Okay, in your syllabus, you have to study CSMA-CD and CSMA-CP. But in order to know that, you should know what is CSMA, carrier sends multiple access. Okay, so we will just go with CSMA. Now, so comparing with the multiple access method, that is the first method, in CSMA, you can minimize the chance of collision. You can minimize the chance of collision and you can increase the performance. So when only the first method was the multiple access method, so in that, whoever station want to transmit, they will be just transmitting without knowing or without understanding anything. They will just transmit whichever data, whichever station has the data to send. Okay, but there was some drawback in that. So the other method, that is CSMA, was developed. So in this CSMA, that is carrier sends multiple access, you can minimize the chances of collision. You can minimize the chances of collision and also you can increase the performance. Okay, now how you can minimize the chances of collision? So what is happening in this is, whichever station wants to transmit a data, they will first sense the carrier or sense the link before trying to use it. Okay, so whatever stations, if they want to transmit the data, the first step, what it will do is, it will sense the carrier or sense the link. Okay, so CSMA is based on the principle sense before transmit or listen before talk. When you want to talk, you have to listen first and then you have to talk. Or if you want to transmit, you have to first sense, then you have to transmit. So CSMA was based on that. But so you might be thinking it reduces the chances of collision. They will be sensing the carrier and then they are transmitting. Then how come collision can happen? Collision. It can only reduce the chances of collision. The collision may happen again because of the propagation delay. That is what it is shown in the diagram. I told CSMA minimizes the chances of collision, but it is not able to eliminate it. Okay, now why it is not able to eliminate it? The collision can happen due to the propagation delay. Now, looking into this diagram, you can just see many stations are connected on a common link. You have stations A, B, etc. up to Z. Now assume station A, at time T1, it transmits its frame. At time T1, station A transmits its frame to Z, to station Z, suppose. Okay, now the frame is in propagation, okay? At the same time, at time T, not at the same time, at time T2, which is much greater than T1, the station Z also senses the medium and it will transmit it frame. See, A's data is on the way only, it has not reached its destination. So by the meantime, when Z senses the link or listen to the link, it is assumes that the line is idle in nature. So what happens? The Z station will transmit it frame. Okay, now at time T3, these two frames collide each other. So collision happens between these two frames. Okay, and you will be having another signal and that will be propagated back at time T4 to Z station and at time T5 to A station. So that is what you can see in the diagram. Understanding how collision has happened, that is mainly due to the propagation delay. If station A at time T1, if it is transmitting the frame, it is not, it reaches the receiver side. That is, suppose it is sending to Z. So when Z senses the medium, it thinks that nothing is there on the medium, so it transmits frame. But on the way, both of it collide each other. And as a result of collision, some signals will be obtaining, and that will be propagated back to the stations Z and A at time T4 and T5, where T5 is much greater than T4, T3, T2, and T1. Okay, understanding what is how the collision can happen in CSMA? Yes or no? What does carrier sends multiple axes? So initially your method was multiple axis. You had some drawback. So CSMA was developed. So CSMA is carrier sense. You are sensing the carrier and then transmitting it. So sensing the carrier, it won't completely eliminate the collision, but what you can do is you can minimize the collision. Okay, now CSMA is based on the principle listen before talk or sense before transmit. Right? And now due to the propagation delay, collision may happen in CSMA protocol. Understood this much? Yes or no? Tulya?
Yes, miss.
Okay. Now, the next thing what you are going to see is the persistence strategies. Now, you have to understand what is persistence. Persistence means prolonged existence of something. In Malayalam, you can call it as tirada. Okay, so you have to follow some procedure, or a station has to follow some procedure that uses or that senses a busy medium. Whenever a station finds the medium is busy, what strategies they have to undergo? And that you can call it as the persistence strategies. What are the procedures they have to follow when they find that the link is busy? Okay, now you can have two different categories of persistence strategy. One is the non-persistent strategy, and another one is the persistent strategy. Now, persistent strategy, again, you can classify it into one persistent and P persistent. I repeat, persistent strategies are nothing but they are the procedure for a station that senses the busy medium. Whenever a station finds a link is busy, you have to follow some procedure, and that is nothing but the persistent strategies. Okay, now the first one is the non-persistence method. Now, what is this non-persistent method? So, non-persistent method, if a station has a frame to send, what it will do is first it will sense the carrier. I hope you all can see the slide. So, in non-persistent method, if a station has a data to send, what it will do is it will first sense the carrier or sense the line. So if the line is idle, it sends immediately. If the line is not idle, then it will wait for a small amount of time or a random amount of time and then senses the line again. That is the concept of non-persistence method. So when you are considering this non-persistence method, this reduces the chances of collision. Now, how it reduces the chances of collision? See, when you are finding the channel is busy, I told you will wait for a random amount of time. Okay, now it is not compulsory that all the station must wait for the same random amount of time and then they transmit the frame. So that waiting time differs between stations. So this type of method, it reduces the chances of collision. Understanding? The first method or the procedure is the non-persistent method. So if a station has a frame to send, what it will do initially is it will sense the line. or the link. Now, if the medium is not busy, it will send the frame immediately. But if the medium is busy, it will wait for a random amount of time and then senses the line again and transmits its data. Understood? What is non-persistent method? So here, this method, that is the non-persistent method, reduces the chances of collision. How it reduces is the waiting time. It differs from station to station. You cannot always tell. It is unlikely that the random amount of time that each station waits is the same. Okay, so that is non-persistent method. Now the other method is called it as the one persistence approach. Now what is this one persistence approach? One persistence approach means whenever a station wants to send a frame, what it will do is it will first sense the link or whether check whether the line is idle or busy. Now, when the line is not idle, or when the line is idle, what it will do is it will send the frame with a probability of 1. So it will immediately send the frame with a probability of 1. Okay, now what happens in this method? It increases the chances of collision because many stations find that the line is idle and they start transmitting their data. Okay, so that is one persistent approach. They are sending the frame with a probability of 1. Okay, so that is the second procedure. Now the third procedure is called it as the P persistent approach. The third one is called it as the P persistence approach. Now you can see in the flow chart, initially you are having many steps in that. So when a station wants to send a frame, what it will do is it will first sense the carrier. Now it will first, after sensing, it may or may not send the data. Now what a station will do is it will, when the line is idle, then what happens here it will send the data with a probability P. It will send the data with a probability P. And it stops from sending with a probability 1 minus P. That is the concept of P persistent approach. So whenever the station finds the link is idle, it may or may not send. Now if it is sending the frame, it will send with a probability P and it stops from sending or refrains from sending with a probability 1 minus P. Now what is the meaning of that? Now what happens if P value is 0.2? So when P value is 0.2, it means that each station after sensing the line and finds it idle, it will send the frame with a probability of 0.2. That means 20% of the time. Understanding? It sends with a probability of 0.2 means 20% of the time only it is taking to send the frame and stops from sending with a probability 1 minus P. 1 minus P, the answer is 0.8. That is 80% of the time. It is refrains from sending or stop from sending the frame. Okay. By the meantime, it generates a random number between 1 and 100. And if the random number, if it is less than 20, the station will send the frame. Otherwise, it will wait or refrains from sending. The meaning is it will wait a slot. Again, it will sense the line and the procedure is continued. Okay, so P persistence approach, it sends with the probability P and stops from sending with the probability 1 minus P. So if the medium is not busy, they will generate a random number, and if the number is not within that limit, they can send the frame. Okay, and it will wait for a random amount of time. If the medium is busy, then it will wait for a random amount of time and the process is continued. Okay, now the P persistence approach, it reduces the chances of collision because a lot of time you are waiting, then refrains from sending, then again waiting, generating a random number. So most of the time it reduces the chances of collision and improves the efficiency. Okay, so these are the different types of procedures a station does when it finds the medium is busy. That is called it as the persistence strategies. Persistence means tirada. So you can have three different methods. One is called it as the non-persistent method. Non-persistent method, they will first, what they have to do is, you will first sense the carrier. If the medium is not busy, they will send the frame immediately. Then if it is busy, they will wait for a random amount of time. So waiting time, it differs from station to station, so it reduces the chances of collision. Now the second one is the one persistent approach. One persistent approach, if it senses the line, if the medium is busy, then if it is not busy, it sends the frame with a probability of 1. So maybe all the stations, when they sense, they will find the line idle and they will send the frame. Okay. Now the third category is the P persistent approach. P persistent means they may or may not send. If they are sending, they will send with a probability P and stops from sending with a probability 1 minus P. Okay, and this method, it reduces the chances of collision and improves the efficiency. So understood what is CSMA and what are the different types of persistence methods. So I repeat, the different types of random access method is, I started with the data link layer functions, two different functions, that is logical link control or the data link control and the medium access control. So medium access control means they are making use of protocols in order to access the medium. Okay, so you can have many types of protocols. The first evolution, it started with multiple access of the medium access, and after that, in order to improve that performance, they have developed the CSMA, carrier sends multiple access. The principle is you will listen the carrier and then only you will be transmitting. So if you want to transmit it like that, each station has to follow some procedure. Okay, and that are called it as the, and what the station do if the channel is busy. And that is nothing but the persistent strategy. So based on any of the persistent strategy, the station will be sending its frame or the data. Understood this much? Jyotish?
Yes, miss.
Understood. Okay. Now, the next part, the what is there in your syllabus is the CSMACD. CSMACD means carrier sends multiple access with collision detection. I repeat, carrier sends multiple access with collision detection. Now, what is the difference between CSMA and CSMACD? In CSMA method, they does not specify the procedure following a collision. They will tell that, okay, when the medium is not busy, they will send for, but sometimes what happens if collision happens? So in that method, they are not telling what happens when a collision is occurred. Okay, so CSMACD, what it does is, it will add some algorithm in order to handle the collision. They add some algorithm to handle the collision. Okay, so it is called carrier sends multiple access collision detection. Now you can see in the diagram, many stations are there and computer A transmits its data. Before the signal reaches computer E, E transmits its data and the collision occurs. Okay, now CSMACD, it discusses what happens, how you are going to handle the collision. Okay, now this is the procedure for CSMACD. So CSMACD, so if any station, if they are having a frame to send, they can send a frame. So any station, the first step is any station can send a frame. Now what it will do is it monitors the medium to see if the transmission was successful. So once they sense the frame, they will check, okay, whether they are getting some acknowledgement from the receiver side. They will sense us, they will wait, or they will monitor the medium and to see if the transmission was a successful one. Okay. Now, if it was a successful one, or when it receives an acknowledgement from the receiver, they find that, okay, it was a perfect transmission. Now, what happens if there is a collision? When there is a collision, the frame needs to send again. Right? When there is a collision, the frame needs to send again. Now, in order to avoid the probability of collision for the second time, first time it sent, collision happened. Now, second time also, they want to reduce the probability of collision. Now, what happens is, it will wait, the station waits. That means it needs to back off. It needs to back off. Back off means it needs to withdraw. But how much it need to wait, or it need to, how much time it stops from sending it. Okay, and that is based upon a back off procedure called exponential back off method. Exponential back off method. Now, what is this exponential back off method? Exponential back off method, the station waits an amount of time between 0 to 2 power n into the maximum propagation time. Here I'm telling the maximum propagation time is nothing but it is the time that is required for a bit to reach the end of the network. See, propagation time. So back of propagation, the total time is given it as it should be between 0 to 0 into 2 power n into the maximum propagation time. Where n, capital N, I told, that is nothing but the attempted transmission. So many times they are attempting, they will reach a limit, so you have to abort the transmission. Okay, so that is the back of how much they have to wait, or how much they have to time they are able to transmit the data. So that is based upon the exponential back off method. Okay, so the meaning is that first time it waits for a time between 0 into 2 power 1 into the maximum propagation delay. Now the second time, if collision happens, what happens? It will wait again for 0 into 2 power 2 into maximum propagation delay for the second time. So different times are there, they have to wait it, and then again they have to sense the meter. So that is the working principle of CSMAC. So CSMACD, I will tell the flowchart in the next class. So now understand that CSMACD is, it is an algorithm that handles the collision. So when a station has a frame to send, it will send the frame and they will monitor the link to check whether the transmission was successful or not. If it receives an acknowledgement from the receiver, it understands that it was a successful transmission. Now, what happens if there is a collision? So, the frame needs to send it again, or the station has to wait. Now, how long it has to wait, that is nothing but the back off method. And here in CSMA-CD, they are following the exponential back off method. Exponential back off method means the waiting time is specified from 0 into 2 power n into the maximum propagation time. Understood this much? The diagram, I will just explain it in the next class. Okay. So today's class summary, I started with medium access methods. You have got different protocols. So if a station wants to send a data, they have to follow some procedure or protocol. And that is called it as the random access protocols. Many types are there, random access protocols. The initial one was multiple access. After that, CSMA was developed. Then another version of CSMA is CSMA-CD and CSMA-C. So CSMA, carrier sends multiple access. It reduces the chances of collision. How? Means they are sensing the line and then only they will be transmitting. But you cannot eliminate the collision in CSMA. Okay. Why? In the sense, due to propagation delays, collision may happen. So the little advanced version of that is CSMA-CD. So CSMA-CD, This describes an algorithm to handle the collision. What happens? So CSMA does not specify. They will be just sending the frame and collision happens. That's it. So what happens when a collision happens? And that procedure is described in CSMAC. Okay. So they, by making use of any of the persistent strategies, they will send the frame and you are having how long you want to retransmit the data again in CSMAC. And you want to reduce the chances of collision. So you have to wait. Now, how long you have to wait, that is based on the back-off method. Usually, exponential back-off method is followed. Okay, understood this much? Yes or no?
Yes, Miss.
Yes, okay. Now, okay. Most probably, let me check it if time permits tomorrow or next hour. If time permits, next hour I'll be conducting the quiz or tomorrow. I will be telling the time depending upon the next hour. Okay. So absentees, Drishya is there?
Yes, present.
Okay. Then Neeraj and Rangit. Neeraj. Neeraj is there? No. Okay, thank you. We will meet in the fifth hour.